So besides this, what other details can we add? If we look up some information, we'll know the steering wheel's rotation and the wheel's rotation are not one-to-one either. There's a specific term for this. It's called steering ratio. The steering ratio is different depending on the car model. I did some quick research, and the steering ratio for a typical passenger car is listed online as between 12-to-1 and 20-to-1. What does that mean? Let's take 12-to-1 as an example. It means the steering wheel turns 12 degrees, and the car wheel will then turn 1 degree. If it's 20-to-1, it means the steering wheel turns 20 degrees and the wheel will turn 1 degree. I also found some cars have an adjustable steering ratio. I think that's pretty cool too. So let's add a feature like that to our rig. Let's add an attribute. We'll call this attribute steering ratio. Let's set the minimum value to 1. And we won't set a maximum value. It doesn't matter. If we are very particular about this, we can set 1. Like I just said, the range for a passenger car is about 12 to 20. So we could set a minimum of 12 and a maximum of 20. I'll set the default to 15 here, picking a value in the middle. Then let's add it. Next, we need to adjust the proportional relationship between the steering wheel and the turning angle. Let's open the node editor again. Add the steering wheel controller. Then show its output nodes. We're mainly looking for this plus-minus average node, because we originally set this up as a one-to-one connection. But now that we have the steering ratio, we need to change it. We know, using 15 as an example, the steering wheel turns 15 degrees, the car turns 1 degree. So let's create a multiply divide node. We're going to do division. Then connect the steering wheel's rotate X. And the other side will be connected to the steering ratio attribute we just created. And don't forget to change the operation to divide. This way, look, if I rotate 15 degrees, then 15 divided by 15 equals 1. The car will then rotate 1 degree. Let's connect output X to that input 1D1 from before. This way, let's take a look. When I rotate it, the car's wheels will turn much slower. So now if we turn the steering wheel all the way, only then will the wheels turn a larger angle. We also need to check, when we move the steering controller, the steering wheel is still being driven one-to-one. So here we also need to make an adjustment. Let's find the steering wheel controller, find the connect group above it and show its inputs. Its input is the sum of the steering controller and the parent driven group's rotation. So we'll take this sum the result, because this result is the car's actual rotation, and multiply it by the steering ratio. That should be the final steering wheel rotation. Because think about it, for the steering wheel, we use its rotate Y divided by steering ratio to get the car's rotation angle. Now we know the car's rotation angle, so we must multiply by steering ratio to get the steering wheel's rotation. So let's use a mult double linear node here. Add connect after the description to show it drives the connect group. Then connect the result from the add double linear node. On the other side, we need to connect the steering ratio attribute. Let's find it, connect it. And this final result connects to the connect group's rotate X. Now let's check. When we steer, the steering wheel's rotation angle will be much larger. It's changed according to the steering ratio. Okay, so at this point, all our settings for the car steering are complete. See you in the next video.